Hey guys, welcome to the Unit 2 review for Business Math A. So again, this is Business Math A. If you have come to this recording by mistake, please note of that now. All right, let's dive in with Lesson 6. So in Lesson 6, we're going to talk about how checking accounts work and how to write a check. We'll start with a couple definitions. So many of these definitions are probably familiar to you, however, some of them might be a little unfamiliar. For example, a check. You're probably familiar with what a check is and even a checking account. Now, we also talk about reconciling our account, which just simply means to compare our check register with a bank statement to make sure that they agree. So making sure that your own personal records of the money that you've been spending matches your bank statement. So what is a check register? Well, that's a record of checking account deposits, withdrawals, and electronic transfers. So again, your own personal record of the funds you've been spending. Now, when it comes to writing a check, it's pretty straightforward, although it can be a little intimidating if you've never had to do it before. In this day and age, many of us don't really have much use for a check. Perhaps you've had to write a check using your parents' checkbook here and there, but most of us don't carry personal checkbooks anymore. Now, if the occasion comes when you do need to write a check, a couple spots of information will need to be filled in. You'll need to write the date, the name of the person to whom the payment will be made, the amount of the check written in numbers, and then the amount of the check written in words. Optionally, you can make a notation on the memo line, and then of course we need a signature. So for example, we would begin by writing the date. And note that all writing should be in pen here, right? We don't want anything someone could erase and perhaps pay themselves more than you wanted to pay them. Next, you write in the name of the person or organization to whom the payment will be made. Next, you'll write the amount of the check as a numeral. So again, number amount goes here, and then notice that this same number is written out in words longhand here. Notice that cents can be represented as a fraction over 100. Often you'll see people draw a line through this space just to fill up the space, and again, just prevent from the possibility of check fraud, somebody perhaps writing in numbers that you didn't put there. Again, memo, optional. Often, if you are at an apartment complex, they will ask you to write perhaps your apartment number in the memo line or something like that. They might even say which month the rent is for. And then you'll finally put your signature. So once you write 2 or 3 checks, it becomes second nature. One thing to practice that we haven't had to call on probably since elementary school is writing out these numbers longhand. So 1204.87. Take a moment and think about what that would look like as words written out. And I know this seems like kind of an elementary skill, but when you haven't done it in a while, it's really easy to accidentally mix numbers around, and you'll find that the amount written on your check may not match the numerical amount, and if so, they might not be able to cash your check. So it's important to remember how to do this. So in this case, 1204.87 would be written 1,204 and 87 over 100. So let's practice filling in a check. So as you see the items appear here, just think about which area on the check they belong. So obviously the signature clearly goes on the signature line. The only other name on the check should be the person that you are writing the check to. The numerical amount goes in the box. The reason goes in the memo line. And the date, of course, just like any other really paper in general, goes on the top corner of the paper. Now make sure you have a good understanding of how to do this, as you will be asked to do this in Project 2. Now what about balancing your account? What does it mean to balance an account? Well, the balance is the amount of money in your account at any given time. For example, if I get paid $200 and I put it in my bank account, I open a bank account and put it in my bank account, my balance is $200. So it's just the amount of money available. Now when you write a check, transfer funds, anything like that, this money will be taken out of your account. So please pay attention here that for the purposes of these coming up lessons that I'll be talking about right now, checks, anytime you see the word check, assume it's a check that you have written to somebody else, not a check that you are receiving. Okay? So that means anytime, for example, if you see a check in the amount of $85 and your previous balance was $300, that means you just spent, so you're going to subtract out that $85, okay? It's really easy to make the mistake because check is kind of a vague word. You're not sure whether you're adding it or subtracting it. So I'm telling you, for the purposes of these upcoming lessons, anytime you see a check, assume it's one that you wrote and that any check amounts will be subtracted from your balance. On the other hand, if you make a deposit, you will add the amount of the deposit to the previous balance. Right? So deposit, you've deposited money in your bank account, you've added money. If you withdraw or write a check or transfer money out, then you take money out of your account. So the formulas or the equations for figuring out your balance is pretty intuitive, right? So our new balance just depends on our old balance and whatever we took out, so however many checks we wrote, what they were worth, any transfers that were taken out, and then we would add any deposits. Pretty intuitive. However, if you feel comfortable, just write out the equations. I would recommend keeping a running tab of all equations for this class. All right, so for example, Stephanie's checking account had a balance of $647.04. So this is, as they say, had, past tense, right? So this is previous balance. She wrote a check to pay her credit card for $245.31 and a check to her babysitter for $150. What is the new balance she should have in her check register? Let's take a moment to consider. So her new balance equals old balance minus spending. So we just subtract off what she spent. She spent $245.31 on the credit card and $150 on the babysitter. So we just subtract those amounts off of our balance. So she spent a grand total of $395.31. We subtract that from this original balance to find that her new balance will be $261.73. So again, pretty intuitive. You'll see that I set it up by putting all of the expenses in parentheses. I found the sum of the expenses and then I subtracted that sum. If it makes more sense for you to write this out differently, you're so welcome to do so. Just ensure that whatever method you use, you're still getting this same end number, 261.73. And I recommend that you practice by, pausing this video as you go. Anytime I go through an equation and you haven't had time to totally write it down, pause the video. If I go through an example quickly, pause the video, okay? So bank statements. So your bank will issue you a statement on the state of your account, perhaps once every 4 weeks or so. So it's important to understand how to read this statement. Now, some may be very detailed, some may just briefly tell you your balance and perhaps your interest. So a couple of things you'll see on this bank statement: previous balance, deposits, checks, service charge, interest, and present balance. So what if you were given this statement? Let's look at Jennifer's statement here in the box. And she wants to know her current balance. This should say balance. So what would she need to do to figure out what her new balance is? Well, she needs to figure out which of these were charges that needed to be subtracted and which were deposits that needed to be added. Well, very clearly we're going to add the $268.15 because it's a deposit. Now remember what I said about checks. For the purposes of our class, these are always going to be subtracted. A service charge is usually a charge that your bank will put on your account every month just for having the account open. And this varies from bank to bank. Some have charges, some don't. Some have $15 charges, some have less, some have more. So something to keep in mind when you're shopping for banks. But a service charge, again, is going to be something subtracted off your balance. Interest, now this is another one to pay close attention to. So in the past, especially those of you who might have taken Business Math B, come to think of interest perhaps as something kind of negative, something that's working against us. In this case, we're talking about interest that is accrued on your account balance, so this is actually a value we will add. So now all we're going to do is take this original $761.29, we're going to add on our positive values, subtract off our negative values, and find our previous balance. Okay, and again, if you prefer looking at the equation, you can write this down. Balance equals previous balance plus deposits minus withdrawals minus service charge plus interest. Fill in all the numbers. This simplifies to $854.99. Now, be careful when you're entering into a calculator. I always recommend that you put each equation into a calculator twice just to double check your numbers. It can be really frustrating. I know I often make silly mistakes, like for example, I may put 146 in the calculator instead of 164. A really simple mistake like that will make your answer wrong, can be a little bit frustrating, so always double check your work as you're going, especially when using calculators. Let's do another example. So here's another statement, and again, we're just going to figure out what the new balance or the present balance of this bank statement is, given that the previous balance is $1,264.32, and then we know our deposits, checks, service charge, and interest. Now for those of you who prefer just to look at this equation and fill in the figures, there you go. For those of you who look for a more intuitive approach, remember deposits are positive things, right? That's stuff being added to your account. That's money you put in. Checks are things that you've written, money you've withdrawn to pay for items or services. A service charge will be subtracted. Interest will be added. So we write down all our numbers, and then we simplify using a calculator. So the balance is $1,331.95. So take a moment to double check that, okay? Get your calculator skills up to speed because you're going to be using them a lot throughout this class. Now what about bank reconciliation? So this refers to payments that may be pending on your account but have not yet gone through. Okay, so if you look at this, adjusted balance equals statement balance minus outstanding checks, right? So outstanding meaning they haven't been applied yet. So perhaps you write somebody a check. So it's an outstanding check until that person takes the time to go to the bank and deposit it, okay? Now it's pretty easy, or pretty straightforward, I would say, to figure out adjusted balance. So for example, let's look at this bank statement. This is Kevin's bank statement. And we're told his previous balance is $246. Now what is his present balance going to be? Now this chart looks a little bit different from the ones we were looking at in the previous slides. However, notice that the information is basically the same. So if you look at this heading, checks and other charges, we're still being told the values that are being subtracted. So remember, checks are things we write to other people and other charges. So this is all going to be stuff that is subtracted. And then this heading on the right, deposits and credits, it's going to be stuff that's added to our account. So it's actually pretty easy to look at. Now notice we also have the date, and then the number is just referring to the check number. So each check will have some sort of index number on the bottom just to keep track of which one's which, okay? So don't worry about that number. Now to figure out our present balance, we just have to figure out, we have to subtract out our checks and other charges, which are told to us in this column, and then we add our deposits and we subtract our service charge. So when you line all that up, it looks like this. And again, notice that if I just look at this column, that's where these three numbers came from. I took the 78.34 charge, the 164.25 charge, the 258.84 charge. I added all those numbers together, and I find that I have a total of $501.43 worth of charges that I'm going to subtract off of my original balance. Okay. For deposits and credits, I take these three numbers, and I've represented them here, and I'm going to find the sum of 364, 164, and 80 to find that in total I deposited $608 into my account in that billing cycle. finally the service charge of $427 is subtracted off. Okay, so obviously setup here is going to be the most tricky thing. And then just, of course, double checking your work as you go. Be careful as you punch these numbers into the calculator. So the present balance is going to be $348.30. Okay, alternatively, if you look at this balance column on the right, notice that I just went through it looking column by column, right? But you could have also gone through it by date, row by row. So for example, this first one, we took 246, the present balance, and subtracted 78.34 because that was a charge, so it was subtracted. And then we added 364 because that was a deposit. We find that this equals 531.66. So now this is our present balance. We subtract off the charge from that date. We add the deposit from that date. And now our new balance is 531.44. We do the same thing again, right? So again, going through it date by date, I don't prefer that method. I think it's really easy to maybe accidentally get the add and subtract symbols backwards. I prefer to do all of my subtractions lumped together as I have here in the parentheses, and all my additions lumped together here. But it's totally up to you which way makes more sense to you. So Andre's statement balance is $597.21, and he has two outstanding checks for $264.25. What is his adjusted balance? So all we need to do is look at his statement balance and subtract his outstanding check. So it's a pretty simple setup here. We just take the statement balance. We know that he has outstanding checks worth $264.25, so we subtract that off. So what we're saying here is that although when he looks at his bank account, he'll see that he has $597 in there, he's written out these checks. So if he goes and spends $597 and then these people cash their checks, he'll overdraft or he'll overdraw, right? The checks will be bounced. So really his adjusted balance, what he can actually spend at this point, is $332.96. Okay, let's do another one. I know those charts can be a little confusing, so let's do one more practice with the charts. All right. Now before I went over how to do it by date, right? So you take the previous balance, which was $367. You subtract off the charge from that date, which is $264.24. So I'm just getting that information where it says charges amount, okay? And then I would add, where it says credits amount, I would add $405.50. I'd figure out whatever that total is. That would be my new balance that I start with here. Again, I think that's a little bit more time consuming, so I'm going to do it the other way, grouping my charges together. So I'm going to start by saying, okay, well I know these were my charges for the month. So I take my previous balance and I subtract off all of my charges. I take all my credits, I lump those together, add up the total number of credits, and then I take my service charge and I subtract off my service charge. I simplify, and I find that my present balance is $329.27. So that's it for lesson 6. Let's move on to lesson 7. We're going to talk about simple interest and savings accounts. So a savings account is just a specific kind of account that earns interest. The amount of money earning interest is known as the principal. Annual interest rate is just the percent of the principal earned as interest in 1 year. The interest itself is the amount of money for the use of a lender's money, the amount of money paid, for the use of the lender's money. And simple interest is interest paid only on the original principal. So a couple things going on here. First of all, I think you all have a good idea of what a savings account is. Principal, for example, if I take out a student loan for $1,000, the principal then is $1,000, okay? My interest rate, my annual interest rate, let's say I take out my student loan for 6.8% interest, that would be my annual interest rate. So as years and months and stuff pass, I'm adding all this interest on, and maybe eventually my balance is somewhere like $120, let's say $1,240, because it's accrued this 6.8% interest over time. So the value of the interest then would be, if $1,000 is the principal, I find that I've now accrued $240 worth of interest. Simple interest, on the other hand, is interest paid only on the original principal. So think about it. Interest will accrue month by month in some cases. For example, with student loans, let's say that it is accruing by month. So maybe in the first month that you take out the loan, you own $1,000. Then maybe it's $1,068, something like this, right? So the number is slowly going up over time. Each time interest is calculated again, they're not calculating interest, they're not charging you that same dollar amount on the original principal, right? They're not always adding 6.8 of 1,000 onto your bill. They're now adding whatever your new balance is. So your interest has driven your balance up, and now you are paying interest on interest, if that makes sense. Simple interest, however, is interest paid only on the original principal itself. So we're not compounding interest on top of itself, it's just paid on the original principal. So let's talk about simple interest. This is the formula. Interest equals principal times rate times time. Now, one special thing to notice about this formula is that in this case, time is always going to be referring to time in years. For those of you who were perhaps in Algebra 2B, you might remember we had a similar formula, and time could have been expressed in weeks or days or minutes or whatever. It didn't matter. You would just write whatever number it was. In this case, we're talking about time in years. So if they tell you something happened for 6 months, you don't write a 6, you write 1/2, because 6 months is 1/2 of a year. Okay, so always convert whatever timeline they give you, always convert it to years for using this equation. Also keep in mind how to convert percentages to decimals. We take the percentage and we divide by 100. So for example, to convert 78% to a decimal, we will divide 78 by 100. Another way of looking at it is just to move the decimal 2 places to the left. So if you start with 78.0, right, there's an invisible 0 there. So 78, we'll move it 2 decimals to the left. Oops. Okay, so from 78% to 0.78. Anytime we're dealing with percentages in equations, we must always convert to decimals, right? So doing something like 100 times 2% doesn't really have a logical value, right? You can't mix apples and oranges. So 100 is a number. 2, they're saying, is a percent. You can't multiply things of different types, right? So you need to convert that 2 to a decimal in order to complete that equation. Okay, let's do a simple interest example. So let's say Nicholas deposits $500 in a savings account at Bank of America. The account pays an APR, so just interest rate, of 2.6%. He makes no other deposits or withdrawals. So he puts $500 in the bank account, the bank gives him 2.6% interest, and then he leaves it alone. After 6 months, how much simple interest does his money earn? Let's find out. So we're just going to plug in all of our values to this I equals PRT equation. We know principal is 500. We know rate is 2.6%, but notice that we've taken that 2.6% and converted it to a decimal by moving this over 2 places. So now we've got 0.026 for rate. Time is 6/12 because, again, we need to convert to years. So 1 year is 12 months, right? And 6 months, to convert, we know that if we take 6 months and divide by 12 months, you can leave it as 6/12 or 1/2 or even 0.50. okay? So you can convert it into the decimal if that's easy for you. Otherwise, if you leave it as 6/12, just be sure if you're typing it into your calculator, it would look like this. You put the parentheses 6 divided by 12, like that, okay? Okay, so simplifying this, 500 times 0.026 times 0.50, we find that the interest after 6 months, he's accrued $6.50, which, hey, that's not a lot, but it's not bad for doing nothing other than depositing money in an account, right? Let's do another example. So same formula. Let's read the information and see what we know. We know that Chelsea earned $211.60 in simple interest. So in this case, interest was given to us, and we're going to be solving for something else. We know the time was 2 years, perfect, and we know the interest rate is 4.6%. So they want to know, what was her principal? How much did she invest? Let's find out. So if interest is $211.60, rate, remember, from 4.6%, we move the decimal over 2 places, we get 0.046. Time equals 2. This is already told to us in years. For example, if they had said 24 months, we would have had to divide by 12 because there are 12 months in a year, and we still would have ended up with 2 as our time. So we need to solve for p. We just need to manipulate this equation and solve for p. So first, let's simplify these two numbers by multiplying them together. Next, we'll divide by 0.092 to get p by itself. And we find that p equals 2,300. So she initially invested $2,300 into the account. Let's do another. The principal on Christina's savings account is $1,500. The APR is 4.5%. What is the simple interest after 9 months? All right, so what do we know? We know the principal, we know the rate, we know the time. We're looking for interest. So principal is $1,500. Rate, again, I would write it down every time, move it over. There's the decimal. 0.045 is the rate. 9 months. So again, we're always, anytime we're dealing with months, we're going to divide by 12, which is 0.75. So I've had the question before, where did you get 0.75 from? So again, you could have typed in 9 divided by 12 instead. But in this case, I knew that if I simplified this, it was equal to 3/4, and I knew that 3/4, 3/4, right, 75 cents, is the same thing as 0.75. So I've plugged in all my information. Now I just carry out the multiplication, and I find that interest equals $50.63. Let's do another. Nathan earned $435.20 in simple interest in 4 years after an annual interest rate of 3.2%. How much did he invest to the nearest dollar? So again, this time we're told interest, time, and rate, and we want principal. So be sure to pay attention. It's really tempting to think that you're always going to be solving for interest, but notice sometimes manipulation will be necessary. In this case, we're going to have to manipulate to find P. So we know interest equals $435.20. We know the rate is 0.032, right? 3.2%. Move the decimal over twice, we get 0.032. Time is 4 because it was already expressed in years. Fill in what we know. Start by simplifying, so multiply those two together. Now divide both sides by 0.128 to get P on its own. P equals 3,400. So as you can see as we go through these, you can go through them pretty quickly. You do have to keep an eye out again whether you're solving for interest, principal, rate, or time. But the actual, once you have this set up, the actual execution is pretty quick. Let's do one more practice of this kind. So, same equation. The principal on George's saving account is $2,200. The APR is 3.8. What is the simple interest after 146 days? So I know principal is $2,200. I know the rate is 0.038 because I moved the decimal over 2 spaces to convert. What will I write for time? So, out of habit, you might want to say 146/12. Well, that doesn't help though, because 12 is the number of months in a year, not the number of days in a year. So if I want to know 46 days is how much of a year, I need to divide by the number of days in a year, which is 365. So time is 146 over 365. And again, you can just leave it like this if you want to. So I went ahead and just typed it into a calculator and it equals 0.4, but I could have left it just as 146 divided by 365 and then done this whole step at once. That would have been fine too. So that's the tricky part there. So notice when you're reading these, if they're in days, they're going to be divided by 365. Months divide by 12, right? So on and so on. Depending on what time value, you're always going to have to convert to years. From here, it's straightforward. We just do our multiplication, find that interest equals $33.44. All right, lesson 8. We're going to set up and solve problems involving compound interest. So we're going to be using compound interest tables, which is just a tool to help us calculate compound interest. And compound interest is what I was talking about before, which is interest that is not only earned on top of original principal, but interest on interest, right? So again, my example, if I took out a loan for $1,000 and I let the interest pile up from month to month, every month as my interest rate, although my interest rate is the same, the balance is higher, so there's more and more interest being added. So the behavior of this money is actually exponential, right? So it starts off not being a big deal that you're paying interest on interest, but eventually it really gets you, okay? And that's why we always advise to pay back interest and pay back principal and loans as soon as possible so that you don't end up in this area, or you might end up, I'm sure you've heard horror stories of loved ones or friends who have had to pay back a loan and ended up paying back twice as much as they originally took out, right? So that's compound interest. Balance is the amount of money that you have in the account. And this could be balance in a good way, like balance in your bank account, but it could be balance on your loan as well. All right, so compound interest. For our purposes, we're going to say that amount equals original principal times amount of $1. So what do I mean amount of $1? We'll see in the next slide. Compound interest equals amount minus original principal. So we're figuring out if our total is $1,300 and I know that I only took out a loan for $1,000, I find that I now have accrued $300 worth of interest. So to find compound interest, we're going to find the total number of interest periods, right? So not all loans work the same way. Some may be compounded daily, monthly, yearly, quarterly, we don't know, right? So we have to find the total number of interest periods, find the interest rate per period, and find the amount for $1 for however many periods at whatever percent per period using this table. Okay, and we'll practice using this table again in the next slide. And then we'll find the amount, and we'll use that to find the compound interest. So I recommend pausing this video, writing down these steps. They'll make more sense in just a second. Okay, so let's say this bank pays 6% interest compounded quarterly on regular savings accounts. Michael deposited $2,000 for 2 years and made no other deposits and no other withdrawals. So he put $2,000 in an account and forgot about it. How much interest did he earn by the end of 2 years? Okay, so step 1, find the total number of interest periods. How do we figure that out? Well, we know that the money was in the account for 2 years and it was compounded quarterly. What does that mean? That means 4 times a year. 4 times yearly, interest was compounded, and this happened for 2 years. So there were 8 interest periods. Now we find the interest rate per period. Interest rate per period equals interest rate over periods in a year. So if the interest rate per period is 6%, we'll divide by 4, and we find that the interest rate per period is 1.5%, or as a decimal, 0.015. Continuing. We're going to use that table. So as I said, we're going to find the amount of $1 for 8 periods at 1.5% using this table. So 8 periods and now we find the amount, right? So again, 8 periods, here's our 1.5%. So the amount, which is this cross section where you see the overlap, is 1.12649, okay? So again, look at the number of interest periods, look at the percent, find the box where they overlap. Now I'm going to take that number, I'm going to multiply it by my original principal, which is $2,000. So the amount equals $2,252.98. So to find the compound interest, I know that I originally had $2,000, so I find the difference of the new amount and the original principal, which is $252.98. So the compound interest accrued during that time was $252.98. Let's practice again. So Sophia deposits $6,000 into her savings account. The money earns 5.5% interest compounded quarterly. Considering no deposits or withdrawals were made in that time, how much will the account be worth in 1.5 years? Let's do the same thing here. So we'll find the total number of interest periods. Again, we're compounding quarterly, and there are 1.5 years. So just like we did before when we multiplied the 8 by 2, or excuse me, the 4 by 2 to get 8, now we'll multiply 4 times 1.5, so 4 periods times 1.5 years. So the total number of interest periods is 6. Now we find the interest rate per period. Interest rate per period equals interest rate divided by periods in a year. Because it is compounded quarterly, there are 4 periods in a year, so we take 5.5%, divide by 4, and we find that our interest rate per period is 1.375%, or 0.01375. Now we use the table. So I'm going to find 6 on my total interest periods and 1.375 right here, which is just the closest number, and I find where they overlap, 1.08538. I'm going to multiply that by the original amount put in the account, which was $6,000. I find the amount equals $6512.28. So her account will be worth $6,512 after 1.5 years. So notice this time, they just wanted to ask us the amount that was in the account, whereas last time they asked for the interest. Had we been asked for the interest, we would have easily been able to find that if we took the new balance, subtracted the original, that this accrued $512.28 worth of interest. So there is also a compound interest formula, and again, if you have taken Algebra 2B concepts, you've seen it, and it looks like this. So A is the amount, final amount, P is principal still, R is rate, and N is number of periods. Steps to finding compound interest. We'll find the rate per period, which is found using annual interest rate over number of periods in a year. We'll find the number of periods, again, just by using the number of years times number of periods in a year, and we'll substitute our information into this formula. We'll find that compound interest by taking the amount in the account and subtracting off original principal, so pretty similar to what we did before. So, Kenneth deposits $3,000 in an account that earns 9% interest compounded monthly. How much compound interest will this account bear after 7 years? So find rate per period. Rate per period equals APR over number of periods per year. The APR was at 9% interest, so we convert it to a decimal, 0.09. Number of periods in a year, because it's compounded monthly and there are 12 months in a year, our number is 12. So our rate per period is 0.0075. Now we find the number of periods. Again, because this is compounded monthly, there are 12 periods in a year, and we're told this goes on for 7 years. So we multiply to get 84 periods. Now we just put our information into the formula. So we know that Kenneth deposited the $3,000. We sub in the 0.0075, which is the rate, and then we raise to 84, so the number of periods. This is going to tell us the final amount, $5,619.61. So pretty significant increase in this balance. So to find the compound interest, we take the amount and we subtract the principal. So $5,619.61 minus $3,000, that's $2,619.61 of interest. So the account has almost doubled in a 7-year period. So think about what that might mean if you're someone, if this is in a bank account, that'd be awesome, but what if this is a loan you've taken out and that you're trying to pay back slowly, okay? So in some cases this could be awesome, and in some cases not so awesome. Let's practice again with this formula. So let's say Jennifer deposits $4,000 in an account that earns 4.6% compounded quarterly. What is the future value of her account after 9 years, provided she does not make any deposits or withdrawals? Step 1, find rate per period. Remember, that's going to be the rate converted into a decimal divided by number of periods in a year. So our rate is 0.046. Because we're compounding quarterly, there are 4 periods in a year, and we find that our rate per period is 0.0115. To find the number of periods, well, again, we know this is compounded quarterly, so 4 periods of a year times 9 years. 4 periods a year times 9 years equals 36 periods. Now we just put the information into the formula. So we know she deposited, that's our principal or present value, $4,000. We know that the rate per period is this 0.0115. And we know that the number of periods is 36. Simplify that formula bit by bit, so start with the parentheses, do the exponent, and then the final step. $6,037.15 is the future value. Okay, so A, I'd think maybe A for after, so after the time has passed. Future value, A is just going to be after the interest has been applied, after the changes have been made. That's what A stands for. So after 9 years, Jennifer's account will have a value of $6,037.15. Pretty cool. All right, lesson 9. So we're going to talk more about compounding interest and demonstrating the relationship between compound interest and exponential growth. I mentioned that briefly a couple minutes ago when I drew that little graph. So compound interest table we've already looked at. Compound interest we've already talked about. So again, if you want to pause the video to write down these definitions, feel free to do so, but we have already gone over them a little bit. Daily compound is just going to be interest that is computed daily, so a period of every day. An annual interest rate, or APR, the percent of principal interest, principal earned as interest, in 1 year. And then annual percentage yield, the rate of return on your investment. So notice the difference. Annual interest rate is the percent of the principal earned as interest in 1 year. Annual percentage yield, again, the rate of return on your investment for a 1-year period. All right. So we had already looked at those two equations, so I won't go over them again. Remember, our steps to finding compound interest, this was one method we talked about, was using the table, finding the amount for $1 for however many days using the given table. Finding the amount using the formulas above, and then finding that compound formula again using both of those equations above. So let's do an example. Richard deposits $3,000 into a savings account that pays 5.5% interest compounded daily. On August 23rd, how much interest has he earned on principal? Find the amount of $1 for however many days using the given table. So we're told that this starts on August 1st, and we want to know what the state of the account is on August 22nd. So 22 days have passed. And now we look at the table, and we just look at and notice that this table is different than the one we looked at before. Now we're talking about compounded daily. Okay, so we look at day 22. The amount is 1.00331. And now, original principal, which was $3,000, we multiply that by that 1.00331, and our new amount is $3,009.93. So not much interest going on there, right? So our compound interest equals amount minus original principal. Compound interest then is only $9.93. So after 22 days, only interest of $9.93. That's not too bad. So let's say Stephen deposits $4,500 in an account that pays 5.5% interest compounded daily. How much interest will he earn in 24 days? All right, so same thing. This time they've just told us the number of days, so we can go right to the table, select 24, and look at the amount, 1.00362. So we'll just take our original principal, $4,500, we'll multiply it by that amount, and that will tell us our new amount, $45,1629. If our original amount was $4,500, we'll subtract that $4,500 off of our new amount to find how much interest has accrued in those 24 days, and it turns out to be $16.29. So again, we were told 24 days, we went to our compounded daily table, we found day 24, we looked at the amount, multiplied it by our original principal. Then we subtracted off our original principal just to find the difference, and that is our compound interest. So please, if you have not already written out these steps, do so. All right, practice again. So let's say on August 7th, Richard deposits $6,000 into a savings account that pays 5.5% interest compounded daily. On August 30th, how much interest has he earned on principal? So we're going to have to figure out, well, how many days elapsed between August 7th and August 30th? 23 days. So looking at our compounded daily chart, we go to day 23. We look at the amount. The amount for day 23 is 1.00347. Now we take our original principal, we multiply by the number from the table. Our new amount is $6,020.82. So that means, and I'm sure for the most part you can do this in your head, it's pretty easy to see the difference. The interest itself is $20.82. Now, compound interest, we talked about this before, but we weren't dividing by n. So, if you remember though, let's take a look at all these. If you remember, we had an equation for rate and we had an equation for time. So now we're just building that equation right into this total formula. Okay, so before we were saying for R, you have to take rates over something, right? And then same thing for time. We were saying, well, you have to know the number of periods and the number of years. Now, instead of making you calculate that separately, we're just saying, you know what, let's throw it all into one equation. And this might be a little bit more easy to keep track of because everything you need to know is in this formula. So again, take a moment, write that down if you haven't. It is equivalent to the other formula we were using. It's just represented a little bit differently. So let's say Michael deposits $3,500 in an account that earns interest at 4.3% APR compounded quarterly. What is his ending balance after 3 years? Let's plug in our information. They want to know his ending balance. So remember, that's going to be A. A is what we end with after we fool around with interest. He deposits $3,500, which means the principal is $3,500. The rate is 4.3%. We convert it to a decimal, 0.043. The number of times compounded annually is 4, and the time in years is 3. So notice the way we plugged this in. We plugged in principal straightforward, And the 4, so 4 is n here. We plugged in our rate, we're dividing by n. We plugged in time, we're multiplying by n. So again, we did that same thing before. We were just simplifying first. So before we would have taken 4 times 3, we would have said, great, that equals 12. And then we would have plugged in 12. Here again, we're just building the steps into the equation. From here, it's a matter of simplifying. So simplify what is, use PEMDAS, use order of operations. So simplify what's in the parentheses. Next, take care of the exponent. And finally, do your last multiplication step. We find that A equals $3,979.18. So that is the ending balance after 3 years. Let's practice that again. So Rachel deposits $7,000 in an account that earns interest at 3.8% APR compounded monthly. What's her ending balance after 5 years? Again, they're asking for ending balance, so we're still solving for A. Watch out though, because at some point they'll probably ask you to solve for P instead. So principal is 7,000, easy enough. Rate, again, pretty easy to identify. Number of times compounded annually. That's the only one you really have to watch out for. So they tell us that it is compounded monthly, so we know there are 12 months in a year. So this is going to be compounded annually 12 times. Time in years, so after 5 years, so T is 5. So we plugged everything in. P equals 7,000. We're taking our rate and divided by that number of times compounded annually, taking our time and multiplying by that number of times compounded annually. And again, order of operations from here. So take care of your simplification. So first you can see I've taken care of the fraction. Now I've added the 1, still working in the parentheses. Simplify that multiplication in the exponent. Now take care of the exponent and do your final multiplication step. Now again, if I were you, I would even recommend pausing this video, taking a practice on your calculator, because sometimes it can be really confusing to plug in these numbers into a calculator all at once. So I totally recommend doing it step by step like this. You can plug it in all like this in one big shot, but you have to be very careful about how you're placing your parentheses. Things can go wrong very easily. So I would recommend taking baby steps, and just as I've broken it down into about 5 steps here to get the solution, I'd say that is advisable unless you're a total calculator pro. Okay, so let's talk about APY, right? So that was going to be percent yield. It tells us what kind of payoff we're getting from our investments. So step 1, solve for A using compound interest formula, right? So that's what we've already been doing, solving for A. Find interest earned, we already know how to do that. We take the amount, A, and we subtract P, the original principal. Then we find the simple interest rate using I equals PRT. So we're kind of combining things that we've already done. Okay? So, for example, suppose Jason opens a savings account with $3,000 that compounds daily. The APR is 4%. He makes no withdrawals or deposits. What is his APY to the nearest 100th of a percent? Pay attention to your digits here. They've asked for 100th of a percent. Let's begin. So step 1, solve for A using compound interest formula, which is what we've just been practicing. So there's our compound interest formula. I know that 3,000 is my principal, so I plugged it in. 0.04 for rate. Because this is compounded daily, n equals 365, and it goes on for 1 year. So we multiply by 1. Just as before, take as many steps as you need to come to the solution, simplifying step by step. We find that A equals $3,122.43. So if my original principal was $3,000 and my ending balance is $31,22.43, I just find the difference and I see that I earned $122.43 of interest. Great. Now, step 3, we're going to plug into that I equals PRT formula from a couple lessons ago. So here, I, the interest, just goes right in, 122.43. Principal we already know. Rate is what we're looking for. And time is 1 year. So plug everything in and let's solve for rate. Okay, so isolating the variable divided by 3,000 on both sides, we find the rate is 0.04081. So the APY, the percentage yield, is about equal to 4.08, which is slightly higher than the APR of 4%. So because this was an account and the interest accrued was in his favor, this is a good APY, right? About equal, just slightly above the APR. So our yield, again, was 0.08% higher than the APR. So again, don't be intimidated. I know that there are a lot of steps to that. I think that's a good way to approach it because it incorporates skills we've been practicing over the last couple lessons. Here's another formula you can use that's not in the book to find APY. So it looks pretty familiar if you'll notice. So APY is just going to equal 1 plus rate over number raised to number times time minus 1. Okay, so here's our example once more. You'll notice that the $3,000 is not even in use yet. So we plugged in the rate, 365 days, plugged in, we simplify, again taking as many steps as necessary. APY equals 0.0408. Okay, so equivalent answer here. Again, it saved us a lot of steps, right, because we didn't have to go through the whole compound interest formula and then take the difference and then plug into that interest formula. So perhaps this might be a faster way for those of you who are comfortable with this. This might be the way to go for APY, okay? If you feel more comfortable, as we did before, using that compound interest formula, finding the difference, and then plugging in and solving for rate, that's totally fine. And again, I like that because you're incorporating skills that you've already been practicing in these lessons. Let's practice again. All right, so we've got a principal of 5,000, an APR of 7.3, no withdrawals or deposits are made, and we're looking for APY to the nearest hundredth of a percent after 1 year. So I'm going to go ahead and use the simplified equation. Again, if you prefer to use that A equals P times 1 plus R over N to the NT, finding the difference and then plugging into the other formula, go ahead and do so. Again, I think this is a little bit more straightforward. So notice that principal balance, again, is going to go unused here. I'm going to plug in my rate, which is 0.073. Because I'm compounding daily, I divide by 365. Likewise, in that exponent, I multiply by 365 times the 1 year. And then I simplify. So again, guys, take care. I know I'm kind of scrolling through the steps quickly. That's really more in the interest of saving time. I encourage you to pause as I go to look at the way I'm simplifying. So notice I took care of this fraction, continued simplifying within the parentheses, simplified the exponent, and now I'm taking the exponent. And finally, I find the difference. Okay, so APY is 0.075723. So about 7.57, which is slightly higher than the APR of 7.30%. So let's take a look at this compounding graph. So the graph shows the exponential rise in balance on an initial investment of $400, and this is just for an example. So $400 over 13 years. Over 13 years at a 7% APR. So after 10 years, how much interest has the investment earned? So this green line, you'll notice, represents balance. So the initial investment was $400, so that's always going to be a horizontal line, right? It's not like our initial investment changes. But the balance, look at the behavior of the balance going up over time. So we're going to take, and we're going to say, okay, great. So you can see balance represented in this purple line. So if I want to know the balance after 10 years, I just locate 10 years and find its location on the graph. Here it is. So my compound interest is going to be the amount minus original principal. So the amount, it looks like there is about $800, right? This amount, about $800. So you get to practice this little graph reading. And my original was $400. So after 10 years, I've doubled the money in my account. Not bad. Let's do another. So here our initial investment is $400, again, 13 years, 7%. After how many years has the investment earned $300 in interest? So a little problem solving necessary here. So $300 in interest would mean that we've added $300 to our original principal. So that would mean that the value in the account would now be $700. So $500, $600, $700. Now just, again, we're going to take 700, and I would just put your finger across until you find the connection. There it is. So it looks like that took about just over 9 or just over 8 years. So it would take approximately 8 years to get that balance. So again, notice that you can either start from years and work your way up to find the amount, or you can start from an amount, work your way over to find the number of years. So it's just like reading any other XY graph. So this graph shows the exponential rise in balance on an initial investment of $1,000 over 15 years at 3% APR. After 11 years, about how much interest has the investment earned? So again, I find 11 on my graph, and I see that this looks like about $1,400, right? So that's about $1,400. So this is the new balance. So I take the new balance of $1,400, I subtract off that original principal, and I find that I have earned about $400 in interest. So after 11 years, $400 of compound interest has accrued. Okay, last lesson, guys, home stretch. We're going to identify average monthly expenditures and interpret a budget sheet. So expenditures are just items that you spend money on. Budget is a plan you use to figure out ways you're going to spend your money, ways you're going to save your money that meets what you want, what you need. The budget sheet itself is the physical document that will be this record. Fixed expenses are things that don't vary from month to month. So for example, your rent is probably the same, an internet bill, a phone bill hopefully should be the same from month to month. Living expenses are routine expenses, right? So food, utility bills, maybe gas and water, pocket expenses, things like that are going to be living expenses. And then our expense summary is a monthly report that compares the amounts you have spent to the amounts that you have budgeted. Emergency fund is exactly what it sounds like. Money that you set aside just in case something happens, medical bills, vehicle repair. And record keeping, just keeping track of the items you spend. Pretty simple, keeping a log. So let's take a look. So your average monthly expenditures equals the sum of monthly expenditures divided by number of months. Pretty straightforward. So let's say Jennifer keeps records of her expenditures and she wants to know how much she spends a month on average. So she's got her records below. Looks like she's been dealing with them for about 4 months. So what are her average monthly expenditures? So we're just going to take the average of 4 months here. So not a new skill, right? We all know how to take an average. So we just add up all of our items, divide by the number of items to find the average. So the total expenditures over 4 months is $15,104.15. Divide by 4, and her average is $3,776.04. And you can see how 1 month she goes a little under, the next one she goes over, under, over, so the average is right in the middle. So what if, presented a little differently, now we have the breakdown by category. So you can see here a family's monthly expenses for October, November, and December. What is the average monthly expenditure for transportation? So they're not asking for everything, just what's the average monthly expenditure for transportation to the nearest cent? So gasoline in October, $135.31. Transportation, right? So car repair is going to count on this. I can't transport myself anywhere if my car is not working, so a car repair of $426.21. The following month, car loan. Sorry about that. So car loan. So again, if you're not paying for your car, you're not going to have a car. So car loan, $264.85. So that's 1 month of expenditures. The next month, spend a little less, about $121.64 on gasoline. No car repairs, but a car loan, same amount. So notice that this is a fixed amount. The following month, gasoline, $154.34, so a little bit more driving in December, and that's steady car loan payment. So what are the average expenditures? Well, we need to add up all of these costs. So take every single one of these items that are highlighted in blue and add them together. We divide by 3 because 3 months passed in the time that we spent all this money. So in 3 months, $1,632.05 were spent on car-related things, which averages to $544.02 a month. So kind of a high transportation budget. Okay, so the family's average monthly expenditure for transportation, $544.02. Let's do another one. So what about last time we did transportation? Let's look at personal necessities. So you have to be careful here. As before, I almost forgot to include the car loan as part of what I was adding up. So here, make sure that you don't forget anything. So personal expenditures, or personal necessities in this case, we're going to just call groceries, clothing, right, incidentals. So in October, just groceries. November, we also had clothing. And we add up all of these expenses. And again, because this is a 3-month period, we divide by 3. So on average, over October, November, and December, $331.76 was spent on personal necessities. So let's say Jason has $175.76 average monthly expenditures for gas during the first quarter of the year. So first quarter meaning the first 3 months. He spent $125.64 in April and $167.34 in May. How much can Jason spend in June to have the same average as the first quarter? So let's think about this. So we'll say he spent this certain amount of money in the first 3 months, so in January through March. So now he's been going along spending money in April and spent some money in May. And now he's saying, you know what? I don't want to go over my first quarter budget. I want to spend just enough so that my average stays the same. So how can that work? And again, notice this is not the total monthly expenditures. This is on average. So he wants to spend the right amount of money so that his average doesn't go above $175.76. So we're going to have to kind of reverse engineer here. So average monthly expenditures equals the sum of monthly expenditures over the number of months. So we're going to plug in. We know everything except what was spent or what will be spent in June. So if my target is an average of $175.76, and I already know the figures for the first 2 months, and I know that it's going to be a 3-month period, I can now just use some algebraic manipulation to solve for my June value. Okay, so multiply by 3 on both sides, do some subtraction, and I find that in June, he can spend $234.30 for gas in order to have the same average for the first quarter. Let's practice again. So let's say Vanessa has $126.54 average monthly expenditures for groceries during the second quarter of the year. She spends $98.35 in July, $136.24 in August. So what can Vanessa spend in September to have the same average as the second quarter? So again, she doesn't want to throw off her average. She wants to stay within that $126.54 average. So what does she need to do? Well, we know her target average, so we plug that in. It's $126.54, so her average. Now we plug in July and August. We don't know September, so we leave it as a variable. We know there are 3 months. Again, we just solve from here for September, so by multiplying by 3 on both sides, subtracting some values over to the left-hand side, we find that Vanessa can spend $145.03 in September in order to have the same average as the second quarter. Now, preparing a budget sheet. So sometimes we overspend. So the amount that we overspend is just the total spent minus the allowance. So if I could have spent $10 and I spent $11, I take 11 minus 10 and I find I overspent $1. So for example, the Johnsons' monthly budget allowed them to spend $264 for groceries. So that's per month. Now during August, September, October, they spent a total, so this isn't an average, this is a total of $924. By how much did they overspend? So if they could spend $264 a month and after 3 months they spent $924, how much did they go over? Well, first of all, the allowance for 3 months, well, to find that, I would take my monthly allowance, so that's for 1 month, and I multiplied it by 3 to figure out how much I could have spent in 3 months. So over 3 months, they shouldn't have spent more than $792, but they spent $924. So if I take the difference, I find they overspent by $132. So kind of a lot of money, but over a 3-month span, really not too bad. So let's say Jennifer moves to a new city and her new expense sheet for entertainment for 1 month is below. Before Jennifer moved to this new city, her entertainment budget was $200 a month. How much more or less are Jennifer's expenses now? So again, the expense sheet below is for 1 month of entertainment. So she spent $40.50 on movies, $25 on refreshments, and $130 on sporting events. So we're just looking for the difference, and remember, difference always means subtraction. So we add up all the expenses in her new city. So this is all that she spent that month, and we find the difference between that and 200. So she actually spent a little less. So that negative money means that she didn't overspend, right? So she had negative $450, which means there was $4.50 left in her budget after the end of the month. All right, last one. So Corey recently switched locations for his business trips. His new expense travel sheet for 1 month is below. So again, this is just the expense for 1 month. Before he switched locations, his travel expenses had a budget of $2,200 a month. So is he spending more or less now is the question. So what do? Well, let's add up everything he spent for that month and compare it to $2,200. So again, taking the sum of all those expenses comes to $2,400.20. Compared to $2,200, we take